Hello and good afternoon, CSI157 Section 841 students at Anne Arundel Community College for the spring 2014 semester. Today's video tutorial for PacketTracer is going to cover PacketTracer activity 9.1.4.6. And in this PacketTracer activity, we have the following network setup where you can see we're going to have a maximum of 25 hosts on each of the subnets here, and then we have our subnetting scenario presented to us over here. Our objectives are going to be to design an IP addressing scheme and to assign IP addresses to network devices and verify connectivity. So in this scenario, we are given the network of 192.168.100.0/24 to subnet and provide the IP addressing for the network shown in the topology. Each LAN in the network requires enough space for at least 25 addresses for end devices, the switch and the router, so 27 total. The connection between R1 to R2 will require an IP address for each end of the link. And so from there, we're pretty confident that we'll be able to do a /30, but let's read on here and see what the design and IP addressing scheme for part 1 is going to require. So subnet the 192.168.100.0/24 network into the appropriate number of subnets. So question A, based on the topology, how many subnets are needed? So by taking a look over here, we can make a very good assumption that for each interface off of the router, we're going to require a subnet. So this will be the exception here. Since this is a point-to-point link, we won't count each of those interfaces as a subnet. So we're going to need 1, 2. This network between the two routers will be 3, and then 4 and 5. So 1, 2, 3, 4, 5. So it looks like we're going to need 5 total subnets. So let me come over here to the pad, and we're going to say, so we need 5 subnets, and I apologize, I'm writing on a bamboo tablet, so my penmanship is not going to be the greatest. All right, how many bits must be borrowed to support the number of subnets in the topology table? And so back over to the pad, you'll remember, so it's a /24, which means that the first 24 bits, 4, 5, 6, 7, 8, dot 1, whoops, dot 1, 2, 3, 4, 5, 6, 7, 8, dot 1, 2, 3, 4, 5, 6, 7, 8. So that's your 24 bits right there that corresponds to the CIDR notation that we see here. Now, the last octet currently for a /24 is 1, 2, 3, 4, 5, 6, 7, 8. Right? So we have 8 bits that remain, and these are the host bits. So you could consider that these are the host bits, and these are, these are your network bits, right? So we're going to subnet this /24, and we want to create a number of networks. And so we know that if we have to have at least 5 subnets, each time we borrow or mask a host bit, right, that would be 2 to the 1, 2 to the 2, which is 4, 2 to the 3, and 2 to the 3, and this is the subnet equation, is 8, right? So what does that mean for our hosts? So we have 1, 2, 3, 4, 5 bits left for the hosts. And if you remember from lecture, the equation for hosts is going to be 2 to the number of host bits that are left, in our case 5, because we're borrowing 3, minus 2 equals. And so 2 to the 5 is 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So 2 to the 5 equals 32, but we're going to subtract 2, so that's going to allow us to have 30 host addresses. And given our scenario where we need to have at least 25 addresses, in addition to 1 for the router and 1 for the switch, we're going to use 27. And so we would have 3 left over, right? So we need 27 total. Now, in terms of the CIDR notation, we've borrowed 3 bits here, right? That first bit is now a 1, this is a 1, and this is a 1. So it's no longer a /24, it is now a /27, right? And we also know that the block size, in terms of our subnetting, right, the block size is 32. So our first network, and I'm going to go ahead, I'll continue to write on this one. I'm going to change the page here in a second. In fact, let me go ahead and change the page now. Let's flip to a new page here. So we know we're going to be using a /27. So oops. I apologize there. Hold on one sec. I got to get out of full screen mode. I hit the, there's a little tab on the pen that makes it do that. So we're going to do a /27, right? So our subnet size, or the block size, will be 32. So what does that mean for us? So our first network is going to be 192.168. Whoops, get that dot in there, .100. And we're going to be .0 as our network ID, all the way, do to .31, right? And so this dot in here, these are all the addresses that'll be in between. So from .1 is our first usable. We'll put that down here. .1 is the first usable, and our last usable is going to be .30, right? So that would be, we'll call this subnet number 1. So subnet number 2 would be 192.168. Apologize, this pen's a little finicky. .100. And if we ended here, our broadcast IP is going to be .31. It would be .32. That's going to be the network ID. And then we have a bunch of addresses. I'm just putting these in the brackets, a bunch of addresses. And then it's going to come up here to .63. And you'll notice between these two, right, these are your broadcast addresses. So if I add 32, which is my block size, right, that's going to give me my next step up to the broadcast addresses, and the same thing here with the network IDs. The increment, or the block size, is 32. And so the usable IP addresses would start with .33 and go all the way to .62. And that is a very bad 2. We'll do 62. So the thing to remember is that your network ID, right, is always going to be even. Your broadcast address for your subnets will always be an odd number. All right, so let's continue down here. So this will be subnet number 2. So subnet number 3 would be 192.168.100. And so we know that the block size, or the increment, is going to be 32. So this is going to be 64. And you can also look here. You can see that it's one more than the broadcast address from the preceding subnet. So we ended at 31 here on subnet number 1, and then it's 32 as your network ID here. The broadcast address is .63, so the next subnet network ID will be .64. And then we've got some addresses in between, right? These are going to be our usables here. And we'll end up with, if I were to add 32 to that, it would be .95. All right, so my first usable IP is going to be .65. And I apologize again, not too good. Looks like a G5 there. .65, and that's going to go all the way up to .94. And that is subnet number 3. So subnet number 3 there. All right. So then our last one here, we'll do 192.168.100. And if we add 32 to 64, we get 96, or even simpler, add 1 to the broadcast address from the preceding subnet, is going to give us .96. So that's our network ID. We'll have some addresses in between, 2, 3. There'll be more than 3, but I just put the little 3 dots there. And then if I were to add 32 to 95, or I could add 32 to 96, which would give me 128, we're going to end up here at 127. And that's our broadcast ID. So again, and I'll put broadcast, and this is broadcast, and this is our broadcast here, and this is my broadcast here. All right, so my first usable would be .97, and then my last usable would be it's going to be .126. All right, ink is changing colors now. Okay, so back over to our scenario. So you can see here, how many subnets did it create? After we borrowed some host bits. So it's actually, the /27 is going to create 8 subnets, right? And it says if your answer is less than 25 hosts required, then you borrowed too many bits. But we're good because we're doing 30 host addresses per subnet. All right, and so here we've got some fields that you could fill in, and then it says fill in the subnet table below. And we didn't create 10 subnets. We're going to go ahead and create 8 subnets because we need to accommodate all of the IP addresses. All right. So now we get into the PacketTracer activity piece where we're going to do some configuration. So assign subnet 0, and they actually start at subnet 0. So let me go back over here. And so this would be our, so we'll say that's subnet 0. This is going to be subnet 1, subnet 2, and this is going to be subnet number 3. Whoops. All right. And so then our final subnet, which would be subnet number 4, so subnet number 3, would be from the 192.168.100. Let's get that in here. Every time I press down hard, it pulls that up. .100. And if I were to add in 1, it's going to be .128. And then it's going to go all the way up to 159. 159. So my usables are going to be .129 to .158, and that would be, this will be subnet number 4. There we go. So we'll leave that up. I apologize, it's quite a mess on the screen there, and hope that actually still makes some sense and will provide some value here as we move forward with the PacketTracer activity. So assign subnet 0 to the LAN connected to the gigabit Ethernet 00 interface of R1. So here's R1, there's gig 00, so let's pull up R1. We'll go to our CLI. We're going to go from user exec mode into privilege exec mode, and we'll go ahead and do a show run real quick, and let's see what we've got here. You can see that the serial interface is configured, but the gigabit Ethernet 00 and 01 are not. And so what we're going to do here is I could also do a show IP interfaces brief, and that's going to show me that gig 00 and 01 are also in a down state. The only interface configured is serial 000, and that's the one that runs between the 2 routers. So it looks like that may already be configured. Okay, so let's go ahead and take a look at assigning subnet 0 to the LAN connected to the gig 00 interface of R1. So we're going to go into global configuration mode, and then I'm going to transition into interface configuration mode, and we're looking at, or interested in configuring gigabit Ethernet 00. All right, so it says assign subnet 0, and again, if you look over here, this is our subnet 0 information here, right? So we know that our first assignable IP is .1, and then we're going to have a series of IPs that will be left over for the remaining hosts that were required, right, up to 25. And so let's go ahead and we're going to follow the convention where the first IP, first usable IP in the subnet is the assignable IP. So let's bring our interface up, and I'm going to do IP address, and we're going to assign 192.168.100.1, and this is critical here, right? Remember, 255, 255, 255. Now, typically with the class C, the default would be 255.255.255.0. However, remember that we've borrowed, we're doing a /27 here, so we've borrowed the first 3 bits of the host address, or the host bits, the first 3 host bits. So the value of the first 3 host bits is 128, and I'm drawing this with my mouse real quick, 128, and then 64, and then 32. Whoa, that is a really bad 32. So there we go. So if you were to add 128 and 64 and 32, you would end up with 224. Oops, 224. So 224 is the decimal representation here, right? Where we have 255, 255, 255. And that last octet, those three host bits that are borrowed have the value of 128, 64, and 32 respectively. And I'm kind of out of space here, but let me see if I can squeeze in with the pen and do, so if we had 1, 2, 3, 4, 5, 6, 7, 8, if these are the last 8 bits, our host bits from a class C, right, /24, and I borrow that one, the value of that location is 128, the value of that location is 64, and the value of that location is 32. So 128 plus 64, 64 plus 32 is going to be 8 and 4 is 12, and 2 is 14, carry the 1, 8, 9, 10, 11, 12, and then carry your 1, it's 224. I apologize, we're getting pretty crowded here. So 224. So that would be the value of the last octet in the subnet mask portion of this assignment. All right, so I'll put a quick description on here, and we'll just say router 1 gig 00 interface, or we'll say GI 00 interface. All right, so that address, or I'm sorry, that interface is now up, and we've assigned the first usable address in that /27 subnet to the router interface, the gig 00 interface. All right, so the next step says assign subnet 1 to the LAN interface connected to the gig 01 interface of router 1. And so let me go ahead and transition here. I'm going to go to interface gigabit Ethernet 0/1. And the first thing we're going to do is we're going to bring the interface up. And that also confirms that, yes, we are working with gigabit Ethernet 0/1. And so we've brought the interface up. And again, assign subnet 1 to that LAN. So here's our subnet 1. And so it looks like our first usable address is going to be the .33. So here it was .1, very convenient. Here it's going to be .33. So we're going to go ahead and go IP address 192.168.100.33. Again, this will be our default gateway address, and we want to make sure we keep the same convention, which is we're using the first available or assignable host IP address in the subnet range to represent our default gateway address on the router. And again, it's 224. It's a /27.224. And so again, this is a /27, and so that would be the value of the subnet mask is a 255.255.255.224. So we'll bring that interface up. I'll throw a quick description on here again, and we'll just say router 1 gigabit Ethernet 0/1 interface. Okay, so now we've configured both gigabit Ethernet 00 and gigabit Ethernet 01. And so let me go ahead and we're going to type end, and that removes us from interface configuration mode, takes us all the way back to privilege exec mode, where I'm going to go ahead and enter the write memory command, or just WRIMEM. In fact, on PacketTracer, I believe if I just do W space M, it builds the configuration as well, but I'm typically typing write mem like that. So, all right, so let's do a show run, see what we've got here. So there are the two interfaces that we just configured. So everything looks good there. So let's do a show IP interfaces brief. Whoops. All right, let's see what we've got here. So 192.168.100.1 for gig 00, 192.168.100.33 for gig 01, and both of our interfaces are in an up and up status. All right, so everything looks good here for right now. So C, assign subnet 2 to the LAN connected to the gigabit Ethernet 00 interface of R2. So we can close down R1. I'm going to pull up R2. Oh, and it might already be, yeah, the configuration for R2 is locked. And so we're going to have to assume that that has been configured over here already. And so these links are green. And then assign subnet 4 to the WAN link between R1 and R2. And again, we can't look at R2, but if we take a look at R1, you can see it's in an up and up state. So there's the serial 000 interface. To bring this down a little bit here, you can see that's the interface there. It is green. It says we're up, and the protocol is up. And the IP address, which would have been from subnet number 4. So here's subnet number 4, and you can see we use the .129, right? So this actually worked out exactly as we had planned, albeit a little messy over here with the penmanship. So, but you can see that we've got the right IP address, and our subnetting did work out. Unfortunately, we're unable to see the interface on, let me see if we can do a show CDP neighbors. And let's do a show CDP neighbor detail, see if it gives us any additional information. All right, so fantastic. You can see that the device ID for R2, right, shows us the address is 158, and that is the last assignable address over here for R2 for serial 000. So we are able to confirm that we're using the first and the last assignable host IP addresses there, right? So switch 1 shows us the address is 192.168.100.2, and so that's very helpful. Shows us that the switch 2 IP is going to be 192.168.100.34, because the subnet's probably going to be, or the default gateway address is going to be .33, which we would have assigned, and then the next address would be .34, and that's assigned to the switch. So again, that command is show CDP neighbors detail, and I can't remember if we've covered this yet, but this is a fantastic command to give you information about your neighbor devices, which are Cisco devices. And the Cisco CDP is Cisco Discovery Protocol, and it works for Cisco devices. So if you had a Brocade device or a Juniper device, you're probably not going to see any information, or you might see something, but not the information that you're seeing here on the screen. But I don't believe you're going to see anything for those devices unless they support CDP. Okay, so that was R1. So fill the addressing table in, right? So we have our information here that we can use to fill the addressing information in. And we've got to come back over here. So assign the IP addresses, configure IP addressing on the R1 LAN interfaces. We did that. Configure IP addressing on switch 3, including the default gateway. So let's come down here to switch number 3. And this is where it's going to become important that we do know the subnets. So I'm on switch 3 in user exec mode. I'm going to transition to privilege exec mode. And let's do a quick show run and see what we've got here. So it looks like we've got some interfaces, and VLAN 1 is not configured, and the gateway is not configured. And so we've done this before in a series of different PacketTracer activities. I'm going to go ahead now and go from privilege exec mode into global config mode. And once I'm in global config mode, let's go ahead. We're going to do our VLAN 1 interface first, and I'm going to immediately bring the interface up. Now, we're on switch number 3. And so if we come back over here, actually, let me slide this guy over here. So switch 3, right, hangs off of router 2, and it hangs off of the gig 00 interface on router 2. So if we come back over here, you can see that step C said assign subnet 2 to the LAN connected to the gigabit Ethernet 00 interface of R2. So subnet 2, which was this messy one here. So .65, 192.168.100.64 is the network ID. So this is our subnet. The first usable IP is .65. So that would be the IP address assigned to the gigabit 00 interface, right? So the next usable IP address would be apologize there, it'll be it keeps pulling that up, .66, right? I'm using my mouse here. So .66 is going to be the first usable IP after we have the default gateway of .65. So I'm going to go ahead and I'm going to use that address here on switch number 3. And I'm in VLAN interface configuration mode. So we'll do IP address 192.168.100.66. And our subnet, we're all /27s, 255.255.255.224. And I'll just put a quick description on here. VLAN 1 interface from subnet number 2. Okay. All right. So let's go ahead and I'm going to type the end command, which is going to take me back to privileged exec mode. And from here, I'm going to do a show IP interfaces brief. And let's take a look when we get down to the VLAN. So here's VLAN 1, and it's in an up and up state, right? And so let me see if I can ping 192.168.100.65, which should be the IP assigned to this gig 00 interface here on router 2. Now, is this going to work? Because we still have some stuff we need to do, and as you can see, it works fantastic, right? So I can actually ping that address, so that's super. Now, the one thing that we needed to do was configure the IP default gateway command. And again, the IP default gateway command, and I got to stress this is one of those commands that I remember long ago when I first saw it, confused me immediately, is that the IP default gateway command is used as the default gateway address for traffic originating from the switch, right? So this would be control plane traffic such as pings and trace routes, and that's very different from IP traffic that is transiting the switch. So if you take a look up here in the diagram, so here's switch 3. So if I'm doing a ping or a trace route from switch 3, and I need to get off of this subnet and go to a different subnet, I need this IP default gateway command to assist that traffic in being able to find the default gateway address. And that is very different from PC3's traffic, which is data plane traffic that's transiting the switch. The PC will have a default gateway entry, so it's not dependent upon this entry that we're doing here. Again, the IP default gateway command on the switch is for traffic generated on the switch, not traffic transiting through the switch. And so again, we know that our default gateway, which we just pinged, is 192.168.100.65. And if you do a question mark with the IP default gateway command, you can see you do not need to put the subnet in there. All right. So I'm going to go ahead and type the end command, and then we're going to go ahead and save our configuration with a write memory. And let's take a look over here. Let's see what we've got, what's next. All right. So we configured IP addressing on switch 3, including the default gateway. Now let's configure IP addressing on PC4, including the default gateway. All right, so I'll close down switch 3. So let's come over to PC4. All right, so here's PC4. And we're going to come into the IP configuration. And actually, let me slide over here real quick because we want to make sure we can see our interface here, because we're going to go back and confirm what subnet got assigned here. And that's really the toughest part of these PacketTracer activities, or at least this specific PacketTracer activity, is being able to, one, come up with the correct subnetting scheme, and then two, being able to apply that and follow along with which subnet is assigned to which router and specifically to which router interface, because that's going to dictate all of the IP addresses in that broadcast domain or that subnet. Okay, so we know we're on PC4, which is attached to switch 4, which is on the gig 01 interface on router 2. So let's roll back up here real quick and let's see. Assign subnet 3 to the LAN connected to the gigabit Ethernet 01 interface of router 2. So this is expecting that the addresses we use will be assigned from subnet number 3. So if we come over here, we can see in subnet number 3, the first usable IP is going to be .97. Again, we're pretty confident that that will be your gateway address. So the next IP would be .98, right? And that could be assigned to switch 4. Let's see if we can peek in here. Yeah, we're not allowed to peek at switch number 4. So that IP might be the VLAN 1 IP here on switch 4. So we're simply going to take the next address after .98, which would be .99. And as long as we're consistent, we should be okay. And so let's take a peek. So that's my IP address. You can see that it fills in based off the class of the address, and a 192 is a class C address, that it fills in the default subnet mask, which is a /24, 255, 255, 255.0. Oops, but we know that we have subnetted this IP space down, and it's a /27, so that last value is going to be .224. Our default gateway for subnet number 3 should be 192.168.100.97. And again, the default gateway address is typically the first host assignable IP address in the subnet range. Okay, so let's pull the command prompt up here and let's take a look. So can I ping myself 192.168.100.99? Right, and that works, no problem. Can I ping 97, which is my default gateway? I certainly can. Now can I ping 98? Let's see if that did get assigned. So it looks like the .98 address was not assigned to switch. Oh, wait, there it is. Okay, great. So it was assigned to switch 4. Spoke too soon. All right, so we've kept with our IP address assignment convention throughout. So let's take a step over here now and see what we've got. So verify connectivity. Says you can only verify connectivity from router 1, switch 3, and PC 4. However, you should be able to ping every IP address listed in the addressing table. So let's go ahead and we'll start with router 1, and I'll ping some different addresses, and I'm gonna be referring over here for my addresses. That way I don't have to scroll up and down. So let's see. Can I ping 192.168.1.97? So let's see if I can ping through to the first assignable or the gateway address on router 2. And it doesn't look like that's going to work from router 1. So let's see, can I, oh, sorry, typo. So used to 192.168.1. So let's do, there we go, 192.168.100.97. So I can ping the gateway address from subnet number 3, which we know is the gig 01 interface on router 2. So can I ping the switch that's over there, switch number 4? Let's see if I can ping switch number 4. And yep, we had some ARP entries that had to be populated. How about PC4? Can I ping PC4? PC4 works great. All right, now let's try to ping subnet number 2, which would be the .65 address, and that's going to be the router 2 gig 00 interface. 66 should be the switch 3 interface because we assign that. And PC3 would be .67. Now we haven't had a chance to peek at PC3 because we can't configure that one, so it might not be .67. And so let's see if maybe it's .68. And again, PC3 may not have an IP address assigned. Let's take a look and see. It's probably locked. Yeah, it's locked up, so that's okay. All right, so I'm back on router 1, and I'm going to try to ping now from subnet 2, or I'm sorry, subnet 1, the .33 address, and I can ping that. That's actually assigned to the router 1 gig 01 interface. Let's see if I can ping 34, which we would think would be the switch 2 IP if it's assigned. Again, we don't have visibility, but yep, there you go. Switch 2 is 34. And let's see if PC2 is 35. And again, PC2 may not have an IP assigned because that was not part of our assignment. All right, and it's going to time out there. And so we're good with connectivity we're good with our connectivity on router 1. Let's take a look at our connectivity. What do we have? Switch number 3. How about PC4? So from PC4, I'm going to try to ping 192.168.100. Let's try .1. And that is the gig 00 interface here on router 1. Let's try .2, which would be our switch interface on switch 1, or should be, although I don't believe we have access into switch 1, but let's take a look here and see if it is .2. All right, and so that's working, right? And we did not configure PC1, which could be .3, right? Or in our addressing scheme would be .3, but we're not concerned about that right now. Okay, so let's go ahead and take a look. Let me check the results and see if we've missed any items here or if we're looking good. All right, so it looks like on PC4 Fast Ethernet 0 that the IP address is incorrect. So let's take a step back here and let's look at PC0. PC4, and we assign .99. But let's see if it wants us to use a different address, and I may have missed that. Answers for 25 hosts. And let's make sure for PC4. Now it may be looking for PC4 to be the last assignable IP, and so let's check that. So the last assignable IP out of subnet number 3 would be 126. And let's put in 126 here and let's see. I don't see where it's indicating it has to be .126. So our connectivity is working, so let's ping through again. Can we ping .2? We can. All right, and let's confirm. Let's check our results now and see if it wanted it to be the last IP address. And in fact, it did. So what we can do is we can confirm that end-to-end connectivity now, knowing that the PCs are the last usable host IP address in their range. So from PC4 to ping PC3, which is on subnet 2, the last address is .94. So let's see. 192.168.100.94, and let's see if that works. Again, assuming that that same paradigm is being used, and sure enough, there it is. And so PC2 is in subnet 1, and so that should be 62. And again, we're probably waiting for some ARP entries, ARP cache to be updated here. And there it is. All right. And then PC1 would be the last usable IP, and that's going to be .30. And so we should see it fail the first time, and then hopefully, there we go. Fantastic. Okay, now one quick note on this PacketTracer activity, specifically this point-to-point link right here that is used between router 1 and router 2. Typically, in a point-to-point link, you're going to use a /30, which gives you 4 IP addresses. And again, before you say, wait a second, there's only supposed to be 2. So 4 total IP addresses, 2 of which can be assigned to hosts. Because the first IP will be your network ID, and the last IP is going to be your broadcast address. But a /30 is a typical convention that's used when you have a point-to-point link between 2 routers that you know is not going to need more than 2 IP addresses. Now, that said, in practice, so that's in theory, a /30 is what you would want to use. In practice, if IP addresses are not being exhausted within your environment, what I've typically seen happen as well is a /29 be assigned between these 2 devices to accommodate maybe down the road if you needed to plug something else in for whatever reason, just to make sure that if this IP addressing scheme here changes, that you've got available IP addresses without having to re-IP, because a /29 will give you a total of 6 usable IPs. Okay, so we went in and we checked our results. We've got 100%. Again, I apologize, a little messy over here. I hope this makes sense, and I hope it's legible. So that was PacketTracer activity 9.1.4.6. And again, this is for Anne Arundel Community College, Spring 2014 CSI157 Section 841 students. All right, I will see all of you on Tuesday night.